Hello and welcome to our discussion of dietary protein. As people who are looking to build muscle, we want to make sure we're optimally supporting this effort with good nutrition. And we know the importance of protein towards building muscle. But what are some of the key considerations that can optimize this process? We're going to dive into that topic, but first I want to talk about what proteins are and why they're important in the body. A dietary protein is one of three major macronutrient groups in food. Macronutrients are where we get our energy. And the other two, of course, are fats and carbohydrates. Dietary proteins are made up of amino acids. And these are think of a protein as a Lego structure, and the amino acids are the Lego pieces. And for our purposes, there are 20 of these pieces, and they all serve essential functions within the body. So they're all important, but 9 of them are actually called essential amino acids. And that's because we can't get them, we can't make them within our bodies from other sources. We need to obtain them from food. So the foods that contain all 9 of these are complete protein food sources, and generally those are animal-derived proteins. Some plant proteins are complete, quinoa and soy, for example, but most others do not have the full complement of 9. Okay, so what is the importance of protein in the human body? We are made up entirely of protein. Structurally, our cells, not just muscle cells, but all of the cells of the tissues of our bodies, organs and things. Proteins are also important as enzymes in the body. So these regulate biochemical reactions, and think of our metabolism. Proteins make up immune molecules and therefore are important in our immune function. And here's the interesting thing. We're not built like a brick building that stands forevermore. We're actually in constant turnover. So it's interesting because it turns out that we replace amino acids and proteins constantly. So it's like a brick building where the bricks that are worn are getting replaced constantly, okay? And it turns out that we turn over about 300 grams of protein in a day. And ultimately, the turnover is such that, any given body part will be a new body part in 50 to 100 days. And this amazing statistic comes from a recent podcast episode where Peter Attia interviews Luc Van Loon, who's a muscle protein physiologist. In fact, we're going to spend some time diving into some of the findings that Dr. Loon has discovered over the course of his life's work in muscle physiology research. But he reminds us that the way we move our bodies and what we nourish it have a significant impact on how that body is then reconstituted. So it turns out that we turn over about 300 grams of protein on average in a day. And of course, less if you're a small person, more if you're a larger person. But anyone who knows how much dietary protein you eat in a day knows that most of that would then be not from your intake. In fact, it's recycled from elsewhere in your body and turned back over. But what we eat is important to keep replenishing that store of amino acids. And the concept of sufficient protein, like what's the amount that you need, is really a relative concept, right? Because there is what is sufficient to prevent disease. So that is the basis of the RDI, or the recommended daily intake set by the World Health Organization. And that number is 0.8 grams per kilogram per day, but that must be considered the minimum for the prevention of disease. Below that, you are considered protein malnourished, and you're at risk of developing a condition of protein malnutrition. And in developing countries, that is a reality. A sad reality in which you can see people develop kwashiorkor. This is the name for the protein malnutrition illness, in which people develop fatigue, irritability, lethargy, and eventually growth failure, loss of muscle, generalized swelling, and reduced immune function. So this highlights the importance of a minimum amount of protein for health. But of course, we're asking a different question. We're asking how to optimize muscle protein building in the context of training. And in this context, we have to think about a different threshold. And we're going to get into that. But I want to talk about this process of synthesizing new proteins. The word synthesis simply means building, making, producing. So when we talk about building new proteins within a muscle cell, what kinds of signals does the muscle cell need in order to do that? The first most important signal is by far and away the stress on the muscle imposed by contractions. And that's really coming from your training. And so that is the most powerful stimulus of muscle protein synthesis, the building of new muscle protein. It turns out that the type of training that you do dictates the predominant type of protein that is synthesized. Okay, all proteins are upregulated or turned on, but certain types of exercise preferentially turn on certain types of muscle proteins compared to others. So if you're someone who does a lot of weightlifting, you're stimulating mainly myofibrillar protein synthesis, and that helps with the contractile components of a muscle cell. Whereas if you do predominantly endurance training, it turns out that you preferentially turn up the synthesis of mitochondrial proteins, which mitochondria are helpful in generating energy for endurance activities. So that's really fascinating, the pathways within the cell that tell it how to do this is under research and investigation and poorly understood. But the muscle can also turn on this process of generating new proteins in response to eating. And so feeding someone protein can also do this. Does it much less powerfully than exercise. But it turns out that dietary protein is another signal to the muscle cell to turn on muscle protein synthesis. And that's the topic of our discussion today. We want to know what factors about proteins make them better at stimulating this process, really. And so that's the topic discussed in this podcast episode, which goes on quite long, so I'm providing a very condensed version of their findings. It turns out that 3 things are very important when it comes to the ability of a protein to stimulate this process of protein synthesis in the muscle. They are 1, protein digestibility, 2, the rate of protein digestion, and 3, the amino acid content of the protein. So let's look at each of those separately. First, the protein digestibility. What is digestibility? Digestibility is basically the percentage of an ingested protein that ultimately is absorbed into your bloodstream, into the body. And it's highest for human milk, or for milk. And that's not surprising because our first exposure to protein food as an infant was human milk. So we almost 100% digest that, and then other proteins go down from there. Okay, animal proteins, as a general rule, have greater amounts of digestibility. It seems that our bodies digest that better than plant-based proteins because presumably plant-based proteins are bound up with fiber. And that's true of most nutrients within plant-derived foods. So higher digestibility equals more robust response within the muscle cell of turning on this protein synthesis. The second factor is the rate of digestion of the protein. So the faster digesting a protein, so the faster that protein appears in the bloodstream, let's say as amino acids in the bloodstream, the greater the stimulus to synthesize new protein within the muscle cell in a 5-hour window after you eat. What about the food impacts the speed of digestion of a protein? Well, first of all, is it a whole meal with other nutrients in it, like carbs and fats, or is it just protein? If it's packaged or eaten with, let's say, carbs and fat, as most meals are, the rate of digestion is slower. And if the protein is processed in some way, it's digested faster. So think of something like an equivalent protein source, beef protein, as a steak, requires us to chew it, requires the churning action of the stomach, the digestive enzymes to get in there. If that same protein is minced, before it's ingested, its rate of digestion is higher. So faster rate of digestion also has a greater impact on the stimulation of protein synthesis within a muscle. And finally, the amino acid content of the protein seems to have an impact. So it turns out that some amino acids have a special role in turning on the signal for a muscle cell to start producing more protein. And this, in particular, leucine is an amino acid that is especially powerful in this regard. And it is a very strong stimulator of mTOR. And this mTOR is an intracellular molecule that is an activator of cell pathways that turn on all of this muscle protein synthesis. There are other pathways, but that's the strongest one, or that's the one that's most powerful. Other amino acids that do this to varying degrees, lysine, methionine. So it obviously, if you have a protein, a dietary protein higher in the concentration of those particular amino acids, they're going to have a stronger impact on muscle protein synthesis. So now we can see the digestibility of a protein, the rate of digestion of the protein, and the amino acid profile of that protein, all taken together will impact that protein's ability to stimulate the synthesis of proteins within a muscle cell. And so if you consider maybe the optimal protein that fits the bill, it would be a whey protein isolate. Why? Well, consider this. Whey is a protein found in milk, and we already know that milk is 100% digestible. Its rate of digestion will be greater because it's been partitioned away from the other parts of milk, which are lactose, the sugar, and in particular, the milk fat. So you've now concentrated the milk protein, and milk protein has two parts. It's 80% casein and 20% whey. And it turns out that the whey fraction has the highest concentration of those amino acids that are the most potent stimulators of muscle protein synthesis. So whey protein in isolation, taken as a powder and mixed in a drink, would therefore be the strongest stimulator of muscle protein synthesis. So it's no surprise that this is the best-selling protein supplement out there, and people are out there doing a workout and slugging back a shake, and they're arguing for the fact that perhaps you need to do this to optimize muscle protein synthesis after a lifting session. But is it true? Right? Do we need to be doing that? Is there any truth in this concept of an anabolic window, and how long does that window stay open? It used to be thought that it was a short window. It was like an hour. And after you did anything, like an endurance activity, you should glug back some glucose, replenish glycogen. And in the same vein, you should glug back some protein in the form of something very rapidly digestible in order to quickly replenish, because you don't have very much time. It turns out that that window is a lot longer than we thought, for both, for glucose and for protein. The muscle turns out to be hungry for these substrates for up to 5 hours, okay, following a bout of exercise. So typically we eat in 4-hour windows or in 4-hour cycles. So there really is no rush, because chances are you're due for a meal within that time frame anyways. And as it turns out, after a single bout of exercise, the muscle is still very receptive to a number of things: insulin signaling, therefore glucose uptake, as well as amino acid uptake. So even the meals in the 24 hours following a single bout of exercise, the muscle is still primed to take in more amino acids than it is at rest. So the conclusion, and a relief for those of us who don't like drinking shakes, is that there really isn't a rush to consume protein following exercise, since we tend to eat within 4-hour blocks, and particularly we often exercise regularly. So for people who do exercise regularly, this window is always open, right? So the question then becomes, what is the minimum effective dose of protein? How much should we be taking in? And they've done studies to compare doses. And the many studies have been done on milk protein concentrates, okay? And in particular, they've shown that when you feed someone 20 grams versus 40 grams of a milk protein concentrate, the response is not within the muscle cell is not statistically significant. It's not meaningfully different. And so 20 grams is as good as 40 grams, but that's if you're considering milk protein concentrates. And we already know, based on the discussion so far, that that is the most digestible, the most easily, rapidly absorbed, and has the highest concentration of all those wonderful, powerful stimulators of muscle protein synthesis. So what of ordinary meals that have proteins combined with other nutrients, which are likely to slow this whole thing down? Suddenly, is there a need for more? And the answer is probably yes, although we don't know exactly how much. Chances are you have to overcome that lower level of digestibility and the lower levels of leucine, lysine, methionine as compared to the milk's protein study. But those studies are the basis of the popular dosing of a whey protein isolate, for example, 20 to 25 grams in a serving. That's where it comes from. So if you're eating real food in a whole meal, maybe the amount is more like 30 or 40, and particularly if you're a larger person, the dose may need to be higher to overcome that, reduced bioavailability, if you will. The question then becomes, well, how much? Like, can we absorb more than a certain amount? And it used to be thought that you couldn't. It used to be thought that if you ate more in a single sitting, it would just go to waste, like you couldn't digest it. They've done studies that compare absorption, and it turns out that if you compare 25 to 100 grams, that 100 grams in one sitting does eventually all get into the body. It just takes a lot longer. But here's the interesting thing. If you take a large dose like that in one sitting, it seems to prolong the window of responsiveness of the muscle, which is really cool, because if you think evolutionarily, that would probably make sense, because if you were a hunter and you caught a prey and you ate it, it would represent a huge protein load at one time, and you might not see another protein meal for a day or two or whatever, and in that time, the muscle is still responding to that single dose. So does that mean we should eat all our protein in one sitting? Probably not. We don't need to. You can distribute your protein intake equally across all your meals throughout the day and still get a really great response. So the clinical takeaways, what at the end of the day does the average person who's lifting weights and wants to optimize their protein really need to know from all this science covered in this podcast episode? Well, first and foremost, the strongest stimulation to muscle protein synthesis is your training. And I want to emphasize that, because the diet is secondary to that. You have to stress the muscle through exercise to really meaningfully make it grow and develop strength, okay? But we can add to the response of our training by optimizing our dietary intake of protein. But it turns out that if we train regularly and eat at regular intervals, that we can just rely on food protein, assuming that we eat a diverse amount of protein. Special considerations may have to be made for populations who rely strictly on plant-derived proteins for the reasons discussed. Okay? But the question still remains, even so, what is the amount that I should be targeting over a day? And your average intake over days is probably what's important. And again, we want to be thinking above the minimum required to prevent illness. So it's thought that on the low end for active people, you should be thinking more like 1.2 grams per kilogram per day. This recommendation may even be higher for people who have higher needs for protein, for whom like protein synthesis rates need to be boosted. For example, someone recovering from a surgery. It turns out also that as we get older, over the age of 65 and plus, we may not absorb and digest protein the same way, thus making the requirement higher for what we ingest to overcome that. And so older populations may benefit from 1.5 grams per kilogram per day. Some sources will recommend that in people who train at a very high level, or strength train 3 to 4 times a week and are trying to gain muscle, would aim even higher, up to 1.8 grams per kilogram per day. I think it's useful to stick to something that you know you can do well and aim for better. Okay? So I'm going to finish the discussion by highlighting certain foods and their protein content. Because naturally the question becomes, well, how do I know? And you should become somewhat familiar with the protein amounts in a typical serving size of different foods that you might eat. So looking at, for example, a turkey breast or chicken breast that's 4 ounces, you'd get almost all of your protein needs in that one food, 30 grams for that meal. Chicken thighs have less, they're smaller, 10 grams. An egg has most of its protein in the white, and it has only 6 grams. So remember that if you're relying on 2 eggs, that's 12 grams. It may not be quite enough for a meal if you're trying to optimize muscle protein synthesis. Dairy protein sources, including cottage cheese and Greek yogurt, a half cup there is between 12 and 14 grams. And then you have plant-derived proteins, which on a serving size basis will have less protein. And remember, that protein is generally has lower digestibility and an amino acid profile that tends to be lower in the anabolic amino acids. So tofu, 3-ounce serving, would contain just under 8 grams. And so you might blend it with something like quinoa and as well with some beans. And the complement of proteins there in that meal would up the protein content and balance the amino acid profile. The last thing I want to talk about is the density of protein in food. So this could be considered the amount in grams of protein for 100 calories of that food, okay? So the greater density might be important for someone who's managing their total caloric intake or their total energy intake. Because if you go chasing higher amounts of protein, you want to be careful not to overconsume calories in a day. So you're going to try and stick to more protein-dense foods. This can be somewhat challenging, and I'll illustrate why. For animal-based proteins, they can come with a large amount of fat, which ups the calorie amount. So a pork sausage that's 100 grams might have 14 grams of protein, but come with 35 grams of fat, and that's 378 calories. These are approximate numbers. If by comparison you choose a 3.5-ounce skinless chicken breast, that would give you a whopping 30 grams of protein, which is almost twice as much, but in half the amount of calories because it's so low in fat. And neither of these foods have much or have any fiber. So if you consider a plant-derived protein, a cup of quinoa, which for some people is quite a lot, it gives you 8 grams of protein. So you have to be willing to eat a large amount of food if you're a plant-based eater. And some of that is bound with fiber because there's a fair bit of fiber there, which has definite health benefits. But you're also consuming 39 grams of carbohydrate, which ups the total calories of that serving of protein to 222 approximately. So you're getting this idea, right? And I put together this graph that I'm going to show you now that shows graphically the amount of protein in a typical serving size of different foods and in relation to the total calories. So along the x-axis you have the total grams of protein in a serving of that food, and along the y-axis the number of calories that come with it. And in the bottom right-hand corner, you have protein-dense foods. This is to say they give you a high amount of protein for the total calories in that food. So you see chicken breast, turkey breast would fall there, fishes, and beef tends to have a little more fat, so the calorie content goes up. And then in something like bacon, you have a lot of fat, so the protein comes with a lot of calories from fat. Excuse me. Likewise, you're getting a lot of calories from the fats associated with the protein in things like nuts and cheese, and fatty meats, for example, like the example with the sausage. Plant-based foods tend to fall in the lower left-hand corner of the graph where the protein content is lower, as are the calories. But you have to remember that as you increase the protein by eating more of these foods, you push the calorie intake with it, right? So there's a commensurate rise in calories. So dietary considerations have to be quite individual. How active are you? How old are you? Are you someone with certain food restrictions? Are you someone, the nutrition is personal, but this at least gives you a little bit of educational background on some of the considerations around the types of proteins that you might eat and their relative impact on this process of building muscle tissue. Okay, so I hope you found that a helpful conversation and discussion, and I welcome you to email me, message me with any questions or feedback. Thanks so much for listening.